Welcome to Super B Productions today here on this Friday afternoon at October the 9th. Today we're going to learn how to add vectors with the XY method and the cosine theta, law of cosines and the law of sines. So here is what we're going to start with. Our first vector is 8 centimeters. We'll say 8.0 for significant digits at 35 degrees. Now, if you're drawing this, you'll put your little protractor on there and you'll measure up to 35 and draw your line. So it's all good. Then we're going to add to that one 12 centimeters at 165 degrees. Now to measure this one, you'll get your little protractor here and you're going to measure around over here to
165?
Yeah, 165. And if you don't have 165 on your calculator, this will be, on the protractor, that'll be what, 165? 15? Yeah, 15 degrees over here, right? Okay, so we're good. 15 degrees. So now, we'll do our resultant, which is right there. And if we measure it, I've already measured this, it's going to be 9.2 centimeters. And our angle is always, okay, our angle is always counterclockwise from 0, this being the x-axis, which is 0. And as one of my students said, the resultant, the tail of the resultant and of the original vector is from 0 right here. So the angle is measured this way. So when we put our protractor on here, measure to the resultant, the answer is 123 degrees. That's when we measure. Okay? So if we want to do an XY method of solving this, it's really simple because you will know about every vector has an XY coordinate. So we're going to take this one and the x component is going to be cosine of theta, cosine of 35 times 8, which my AP students in the audience have already put this in their calculator, which is what?
Is that the x?
Yes.
That's 6.6.
Okay, that's 6.6. That's cosine 35 times 8. And then, of course, for the y component, it's going to be sine 35 times 8, which is
4.6.
4.6. Now, the easy way to always solve, okay, where's the black marker? Black marker here. Okay, to find this angle here, the x, which would be over here, which you can see will be in the negative, and the y, which would be positive. You use cosine of 165 times 8 gives you
Negative 11.6.
negative 11.6. And then, of course, we use sine of 165 to get the y component, which is sine 165 times 8 equals
3.1.
3.1. Cool. So now we've got the x components of both vectors. We got the y components of both vectors. So if we add them, we get the result of the resultant vector. Okay, the result. So that's the resultant. So this is negative 5. And this is
7.7.
7.7. So that's A and that's B. So we can use Pythagoras to find. So this right here ends up being negative 5, and this ends up being 7.7. So a squared plus b squared equals c squared, which is 9.2 centimeters, which is 5.0 squared plus 7.7 squared equals c squared, and c equals 9.2. Then to find the angle, we can find this angle right here, subtract it from 180. It should give us 123. So we'll see tan, which tan to the minus 1 of 7.7 over a negative 5 will give us, we're working on it. My audience participation is punching this up. As you are out there in the video land, I'm quite sure.
Negative 57 degrees.
Which gives you a negative 57 degrees, which tells you it's going clockwise, so negative 57 from 180 gives you 123 degrees. Ta-da! So our resultant is 9.2 centimeters at 123 degrees, which we saw with the XY method, and we measured it. We must have been right because we got the same. Yes, we did, and Trooper is participating as well. Thank you very much, sir. So the result is that. Now we're going to find it using the law of cosines and the law of sines. The law of cosines is this. Now, the cool thing about this works for an angle that's not a right triangle. If it were a right triangle, you'll recognize this part as Pythagorean theorem because the cosine of 90 is 0. So you won't have that with a right triangle. But with not a right triangle, you can use this. So the first thing we do is find C. And C is always the angle opposite the resultant. So this will be little c. So this angle down here will be A, that's little a, this will be B, and that's little b. So now we can plug in the numbers, but first we have to find what angle C is. So we use a little alternate interior method here. If this is 35, then that is 35. And if that is 165, that is 15, because 165 from 180 is 15. So 15 and 35 is 50. So C is 50. So we have C squared equals side A is 12. 12 squared plus 5 squared minus 2 times 12 times 5 times cosine of 50. And lo and behold, when you solve it, you get 9.2 centimeters. Whoop, whoop. Works both ways. Thank you very much. Now, to solve angle A, we're going to use the law of sines. Sine A over A equals sine C over C. We're looking for that. So we'll multiply A times both sides, and we'll get this. If we divide by sine, we get A equals sine to the negative 1 sine theta, right? So, yeah. Sine minus 1 over, what am I doing? Oh, yeah, times sine CA over C. There we go. Okay, so we have sine to the minus 1 times sine CA over C. So, there we go. And lo and behold, when we throw all those numbers in, we get, what do we get?
Alright, so what are we putting in?
We got arctan or shift tan, sine, shift sine, sine of 50 times 12 over 9.2.
9.2?
Yeah.
87.7.
Okay, so our answer, this A angle is 87.7 degrees. So guess what we do? We add the 87.7 to the 35, and what do we get? 123. Correct?
Yeah.
We get 123 degrees. So the resultant with the law of cosines, the law of sines, is 9.2 centimeters at 123 degrees. With the XY method, it's 9.2 centimeters at 123 degrees. It's the old-fashioned draw and measure it. It's 9.2 centimeters, 123 centimeters. Contact me at jbanks@stjoebruins.com if you have any questions. Thanks for joining us. Ooh, I'm worn out.